Okay. Okay, so today we're going to be doing just tons of examples. We're going to be solving logarithmic and exponential equations. And the general theme for solving kind of holds true. Just like when we solve a radical, we isolate the radical. That's our first step, is to isolate the logarithm. So here's the thing. Isolating the logarithm means get all the logarithms on one side of the equation and everything else on the other side. Now there is one time when we won't have all the logarithms on one side. If you only have period to end of story 2 logarithms, so do you see how we have a 2 here? Because we have more involved here, we're going to get all the logarithms to one side. But if we only had a logarithm, one logarithm, we'll want a logarithm on both sides of the equation. However, it would still work to have all the logarithms on one side, so you want to just stick to a common thing. So get out the logarithms on one side of the equation. Then we have to put the logarithms together with properties of logarithms. So you do have to do it correctly when you put them together. So we know how to do that. That's what we learned last time. And then third, undo the logarithm with correct inverse. Now understand, you can only undo a logarithm if it is one logarithm. You can't, it's just like, I'll show you in a second what I mean by that. Okay, and then fourth, just solve using algebra. And then we know if we're solving a logarithmic equation, we cannot have, when we plug it in, we can't have a negative inside or a 0 inside a logarithm. So we just got to check for extraneous solutions. So on this first example here, we're going to get all the logarithms to one side and everything else to the other side. So I'm going to add log base 4 of x to both sides. So that's our first step. So then we have log base 4 of x minus 6. And then we have plus log base 6 of x. Oh, it's log base 4. Sorry, log base 4 of x equals 2. Now the reason we did that is because now we can do our second step, which is put the logarithms together with properties of logarithms. So everybody, a lot of people will want to say, now I can undo the logarithm, base 4. And they'll base 4 both sides. But that's like breaking a forbidden rule. Because of the plus sign, you can't base 4. Just like we can't square across a plus sign. Like, you know, if we have x minus 1 squared, we can't just square that and square that across a subtraction or addition sign. That's the same thing. You can't just base 4 across an addition sign. But when you add 2 logarithms with the same base, can't you multiply? When you multiply, you add, or when you add, you multiply. So we can put this as 1 log base 4. So 1 log base 4, parentheses, and we have our x minus 6, plus sign means times, x. And now we have 1 log base 4. Do you have any questions on how I put that together? Because that's from last time, and that's equal to 2. So now from there, because we have only 1 logarithm, we can undo the logarithm with the correct inverse. So we're going to base 4 both sides, because that's what undoes log base 4. So now base 4, log base 4 cancel out. And we have x minus 6 times x. That's equal to 4 squared, which is 16. Now from here we have a quadratic, correct? So we need to actually distribute this through and get it in standard form. So now we can solve. So we have our x squared minus 6x equals 16. So we have x squared minus 6x minus 16 equals 0. And now we'll factor it. What multiplies to be negative 16 and adds up to be negative 6. 8 times 2, negative 8. That quick factors to be x minus 8, x plus 2. Therefore, x equals 8 and x equals negative 2. And now we've got to check for extraneous solutions. Do not just say, oh, a negative means we're going to throw out that answer. That's not true. Even if you have a positive, you might end up throwing it out. It depends on if you plug it in, if it's still negative inside the parentheses. So let's go back up. If we plug in 8, when we have 8 minus 6, which is positive 2, so all is good. If I plug in 8 right here, it's positive. So that one's good. If we plug in a negative 2, negative 2 minus 6 is negative 8. The log of a negative can't happen. So in this one, yes, that negative will be extraneous. So our only solution would be 8. Do we have questions on that? Pretty easy, right? Overall. Okay, let's do some more examples. This is how we solve the exponential equation. Same idea. First, isolate the base. Just like we had to isolate the logarithm, you've got to isolate the base. Now remember, the base is the part that has the x in the exponent. That's the base part. Isolate it all by itself completely. Then we can undo the base using the appropriate logarithm, and then we're going to solve using algebra. So here we go. Get the base alone. Which one's the base in this? 5. Okay, I'm going to change the color. Get that alone. So our first step would be 2. Subtract 1. Good. So then we have 3 times 5 raised to the x minus 1 equals, if you subtract 1, you get 6. Then what? Divide by 3. So now we have base 5 raised to the x minus 1 equals 2. Now you cannot divide by a base. That's not what undoes a base. What undoes a base 5? A log base 5, right? That's the correct inverse. So log base 5 both sides. So now log base 5 and base 5 cancel out. X minus 1 drops down. And then on this side we have this. Log to the base 5 of 2. Now before you move on, remember that this can be calculated, but only if we have a base 10. So we use the change of base formula to rewrite that. So remember, the change of base formula allows us to rewrite that as log of 2 divided by log of 5. Remember, it's what's in parentheses that goes on top. So we have this, x minus 1 equals log of 2 divided by log of 5. Now to get x alone, what will we do? Add 1. So my answer is this. My exact answer I'll leave as a logarithm, and then I'll also calculate the decimal. So we have log of 2 divided by log of 5, and then we have plus 1. That is our answer. That's the exact answer. Now everyone practice typing it into your calculator and give me a decimal, please. It's super long. Let's write down the full decimal. So it's 1. Perfect. That's what I would write down, the entire decimal, if it's not outrageous, honestly. Unless in the instructions it does say round, the nearest whatever. Now, once again, everybody, there will not be extraneous solutions for exponentials. Why? Because can't I plug anything into an exponent? Positives, negatives, zeros? Yes. So this one won't have extraneous solutions. Okay, awesome. Let's do another one. So now, solving the logarithm. This is one of the times where, first of all, everybody, there are 2 logarithms. Now, normally I would say get all the logarithms on one side and everything else on the other side. But you see how there's only logarithms? There's not anything else? I'm going to leave 1 logarithm on one side and 1 logarithm on the other side. However, it would not be incorrect to bring the logarithm over. You just have to write 0, though, on the other side. Okay, so I'm just going to leave them. Now, you cannot, everybody listen. You cannot undo a logarithm unless it's just a logarithm. So look, people say I'm going to base 3 both sides. But what about the 2? You can't just base 3 a piece of a side. So we first got to take care of the 2 in front, times in front. Can anyone remember from last time what a 2 times in front really is? It's an exponent. So we're going to take this up, and that is an equivalent statement. So now we have this. Log to the base 3 of x squared equals log to the base 3 of 25. And now we have just log base 3 and just log base 3. So we're all good. So now couldn't we base 3 both sides of the equation? So we'll undo log base 3 with the base 3. And in this particular problem, base 3 and log of the base 3 cancel out on the left, giving me x squared. And on the right, it happens to cancel out too. Base 3 and log of the base 3 cancel out, and we get 25. So now you have a quadratic equation. Solve it by the most appropriate method. This one would be taking square roots, right? So we'll square root both sides. So we get x is equal to plus and minus 5. Because the square root of 25 is 5. Then we got to check. Can we plug in a negative 5 into right here? It'll be negative inside the logarithm, right? So we throw out the negative. We've got to check logarithm equations for extraneous solutions. So in this one, we'll throw out the negative, so x equals 5. We plug in 5, it's positive. So. All right, here we go. So once again, log the base 2 of x minus 2 plus log the base 2 of x equals 3. Now notice there's multiple logarithms and then there's other stuff, like the 3. So get all the logarithms to one side of the equation and everything else to the other side. Check. Okay, now we cannot watch, people want to go base 2. Base 2, base 2. You just broke the forbidden rule. You can't do that across an addition sign, just like the other forbidden rule. So instead, we should put the logarithms together so that there's only one logarithm. When you add, you multiply. So this is log base 2 of x minus 2 times x, right, equals 3. And now we can undo log base 2 with the base 2. Base 2 and log of base 2 undo each other. So then we have x minus 2 times x equals 2 to the third power is 8. So then we would say we have a quadratic x squared minus 2x minus 8 equals 0, and we'll factor. What multiplies to be negative 8 and adds up to be negative 2. 4 times 2, negative 4. So this factors to be x minus 4, x plus 2. Therefore, my solutions are 4 and negative 2. And we'd say we started with a logarithm, so we got to check them. If we plug in a negative 2, it becomes negative, doesn't it, inside? So once again, this one happens to have that the negative cancels out. 4 would be our only solution then. Okay, let's solve this one. Okay, so it's an exponential equation. What should I do first? Isolate the base. Good. So we would subtract 2 over. So then we have base 3 to the x equals 5 because I subtract 2. Then what? Good. Log base 3 both sides. So then log base 3 and base 3 cancel out. X drops down. So x is equal to log to the base 3 of 5, which is not my final answer. How would I calculate that? The change of base formula, right? So we have x is equal to log of 5 divided by log of 3. There's your exact answer. Then you would type it into your calculator and get the decimal. Thank you. 1.464973. That's a 3. 5, 2, 1. Thank you. This one by yourself. Make sure we're good with some exponentials. So isolate the base, undo the base, solve for x. So let's see if you can get it by yourself. So you should have got log of 3 divided by log of 5 divided by 2. Did you get it? Sweet. Let's see what the decimal would be on that one.
I got
0.34130. You what? Oh, there is. What's after 0? Okay, perfect. All right, how about you do this one by yourself? Did you get ln of 5/2 divided by 3? Sweet, we're doing good. Okay, let's hear the decimal. 0.3044. Cool. Next one. All right, I think we get the picture with these ones, with the e's. So we'd add 5, divide by 3, ln, and then divide both sides by a negative. Do I need to check for an extraneous solution on in this one? No, it's an exponential equation, so we can plug anything into the exponent. Okay, all right, let's look at this one. Would it be appropriate to base 3, base 3, base 3? No, because you can't do that across the subtraction sign. So what should we do instead here? Combine them, yep. So log the base 3 of what? X plus 5 divided by x. When you subtract, you divide. Way to remember, equals 2. And now can I undo log base 3? So we'd base 3 both sides. Log base 3 and base 3 cancel out. So then we have x plus 5 over x equals 3 squared. 9. Okay, how would we solve this one? Yeah, there's so many ways to get. We can get a common. Isn't this a rational equation? So she's saying get a common denominator. Yes, I agree. So then this is x plus 5 over x equals 9 over 1. So why don't we multiply by x over x? And now that I have a common denominator, can't I ignore it? Yes. Okay, let's solve. So now we have x plus 5 equals 9x. And then what? Minus x. 5 is equal to 8x. Divide by 8. So x is equal to 5 over 8. Okay, let's go plug it in and make sure it's okay, because it was a logarithm after all. If I plug in 5/8 here, 5/8 plus 5, isn't that going to be positive? 5/8 in here is positive, so we're good. Okay, awesome. All right, how do you think we should do this one? Combine. Do you think I should bring this logarithm over? You could, but you don't have to. Does everybody understand why? If you leave it on this side, it'll be okay because isn't there only one logarithm? So we can base 4 it. But we wouldn't be able to listen. It's still breaking the forbidden rule to go base 4, base 4, base 4. You did it across an addition sign. So instead you would have to put this side together real quick. So we would have log the base 4 of x plus 3 times x, right? When you add, you multiply. That's equal to log the base 4 of 3. But understand, guys, if you would have subtracted that over... Oh, it's times x minus 6. Good catch. Okay, so it would have still been okay to subtract that over. So then wouldn't it have just been divided by 3 here? It'll all work out mathematically the same way because we're not breaking any mathematical rules. Okay, so then, but on this side there'd be a 0, correct? Okay. All right, so now let's undo it with a base 4 to both sides. We're not breaking any forbidden rules because there's only one logarithm there. So then we have our x plus 3 times x minus 6 equals, we're not breaking forbidden rules over here because there's only one log base 4 and base 4 equals 3. You'd say, I have to solve a quadratic by getting it set equal to 0 and putting it in standard form. So we have x squared minus 6x plus 3x minus 18 equals 3. So then we have x squared minus 3x. I'm going to subtract 3. So minus 21 equals 0. So then you factor what multiplies to be negative 21 and adds up to be negative 3. 7 and 4. No, it's not. Did I do something wrong? What? Oh, I wrote 27. No wonder. Because it's actually 21, right? So it works. No, wait. 7 times 4 is not 21. That's 28, isn't it?
7 times 4 is 21. 7 minus 4 is
It's okay, sorry. This is negative 21. Okay, so any factors? No? Then we gotta use quadratic formula, and if we get i's, there's no solution. So let's do quadratic formula real quick. I don't remember having to do quadratic formula, but maybe I made one up. Maybe I made this one up. I don't remember making it up though. Okay, here we go. Let's not freak out because we know how to solve quadratics that have that can't factor. So here, let's quickly do it. So x equals negative b, so that'd be positive 3 plus or minus the square root of b squared. Negative 3 squared minus 4 times a times c. This is going to be, oh, it'll be positive underneath, so we're okay. All over 2 times a. So let's calculate underneath real quick. More than one person, because that's where people usually have a hard time. No, x is equal to 3, but good question. Plus or minus, I want the exact, like what was just underneath. It's 23? Oh, 93. Okay, cool. Square root of 93. Okay, so then my two answers are this. X is equal to 3 plus root 93 over 2. And x is equal to 3 minus root 93 all over 2. Now, yes, I want the decimal as well. So do 3 plus 93. Make sure you hit enter. And then divide by 2. You do have to hit enter first. And then do 3 minus root 93. And then hit enter and divide by 2. Because I need both decimals. Thank you. 6.3. It's longer than that, but we'll round for now. And then what's this one? Negative 3.3. Okay, let's see if we can plug in positive, and we plug in positive, will it be positive inside? 6.3? Yeah, right? If I plug in the negative 3.3, will it be negative inside? Yeah. And then same here, right? So we got to throw out the negative one. So our answer would be like this. Oopsies.
Is there ever going to be like a solution that's negative for negative?
Yes.
Oh,
Because you could plug in a negative and it be positive inside because it's big enough. Does that make, like, it just depends on the problem. All right, what can I base? Okay, question. This is a question for you because I see people get tricked. Can I base 4? Base 4. No, because of why? Because of the 5. That's like pretending the 5 is not there, and it is there. So what should I do with it? Put it as an exponent, right? So we have log base 4 of x to the 5th power equals log base 4 of 32. And now isn't it okay to base 4? That cancels out. X to the 5th equals 32. Then what? 5th root both sides. So x is equal to the 5th root of 32. Do we need a plus or minus here? No, we don't. It's 2. Perfect. We don't need a plus or minus. Okay, let's check it. If I plug in 2 inside the logarithm, it's not negative. Okay, great. All right. I think we get the picture, but do you want to try this one by yourself, or do you guys think you could do it? Okay, just verbally state to me for the video what you would do. Minus 5. Divide by 3. Log base 2 both sides. Then you would need to change your base formula, right? And then you would add 1 after that. Okay. Cool. Okay, this one we need to do together. Write it down. Okay. So we have base 1/3 raised to the 4 over x plus 1 equals base 2. What's hard with this one is people have a hard time, so I'm going to write 2 to the 1st. You see there's 2 bases here? And you can't rewrite either of them as each other. So the hard thing is people say, well, which one should I log base? Should I log base 1/3? Or should I log base 2 both sides? Well, it doesn't matter. It really doesn't. You can do either or. But I mean, honestly, either or will work completely the exact same mathematically. So I'm going to log base 1/3 both sides only because the x bar is in this part of the equation, but either one would work. So let's log base 1/3 both sides. Oh, I guess people would have known to do that, probably. Would you? That one? Yes. Okay, this is building us up to this next part. So then we have 4 over x plus 1 equals log to the base 1/3 of 2. How do we rewrite that side? So log of 2 divided by log of a third. Right? And that's equal to 4 over x plus 1. Now what? We could do it the way of thinking of common denominators, or couldn't we just cross multiply to make our life? That is getting a common denominator, but with a trick. Cross multiplication is just a trick. So that's fine. Can't we cross multiply here? Yes, so let's multiply up log of 1/3, and we'll multiply up x plus 1. Because that's cross multiplication, correct everybody? I multiplied up a log of a third, and I multiplied up x plus 1. Cross multiplication. It's the exact same thing as getting a common denominator. Think about it. When I multiply this one by x plus 1 over x plus 1. When I multiply this one by log of a third over log of a third. And then the denominators wouldn't matter. Cross multiplication is getting a common denominator, but like with a trick. Okay, so then from there, let's solve. 4, don't freak out. Log of a third is just a number. Like this is just a number here. There's no variables. We just have 4 log of a third equals log of 2 times x plus 1. Okay, what should I do next? Trying to get x alone. We can't subtract a 1 because it's times to log of 2. You're almost there, but what undoes multiplication? Division, so we divide both sides by log of 2, but you are right there close. So now I have 4 log of a third divided by log of 2, and then we have equals x plus 1, and then we literally have one last step. Minus 1? Okay. Here we go. 4 log of a third divided by log of 2, and then after that minus 1 equals x. The hard part would be typing that into your calculator, right? So I think you should try it real quick. It's just 4 log of 1/3, so that's 4 times log of a third. 4 log of 1/3, hit enter, divided by log of 2, hit enter, minus 1. Negative 7.33-ish. It's longer than that. X is equal to negative 7.33. Let's check if that solution is appropriate. We started with an exponential. Do I even need to check? No, because it's okay to have negatives as exponents. But you could check by plugging it back in, but you have to type in the entire decimal to really check it. Okay. Okay, so the reason I'm doing so many examples is just because I wanted to make sure we're good. If you can just tell me verbally what to do here, we won't do it. Add 1. Let's do it. That's not wrong, but let's do it smarter. How would we better undo, instead of dividing by a half, what would be the more appropriate way to get rid of a half? Times by 2. Good. I like the idea better just because then the math will come out prettier, everybody. You won't have to, the math will come out pretty. So you'd add 1 times by 2, correct? ln, both sides, right? Then subtract 5, divide by 2. Okay, good. This is the one where notice there's x's in both bases. So this one is the one I was talking about a second ago when I was like, oh, it doesn't matter. That one was more obvious. So we have base 3 raised to the x plus 1 equals base 2 raised to the x. So once again, you can say there's 2 x's, 1 in each exponent, and there's 2 different bases. So we have to choose one or the other. You can't just log base 3 of this side and log base 2 of that side, because you've done 2 different things. You have to do the same thing to both sides of the equation. So which one do you want to do, log of base 3 or log of 2? It does not matter. It literally mathematically will come out the same way. What I always do is, the one with more than one term, it's just the math will come out prettier if you undo that base. So let's log base 3 both sides. It won't matter though if you were to do it the other way. So now log base 3 and base 3 cancel out, correct? So then we have x plus 1 drop down. That's equal to, now be careful, this is what we're looking at. Log base 3 of 2 raised to the x power, aren't we? Now, it almost makes us want to freak out here, but we don't need to. Here's why. Isn't that if we have something that's an exponent, I can work backwards and bring it down? Mathematically, logarithms tell us we can do that. So we would want to bring it out of the exponent. So we have x plus 1 equals x times log base 3 of 2. So now to solve for x, this is a time sign, isn't it? There's two x's, so you're not going to want to divide by log base 3 of 2, are you? No, because then that's just going to make it uglier. But remember, when solving, if you have two of the same variable, don't you get everything with that variable on one side and everything else on the other side? Yeah, so let's bring all the x's to one side. So what I'm going to do is subtract x over. We're almost done. So we have 1 is equal to x log to the base 3 of 2 minus x. Now what can I factor out on the right? An x. So now I can pull out an x and then I'll only have one variable. So now I have 1 is equal to pull out an x, divide by x, divide by x. So then left is log to the base 3 of 2 minus 1. And now we have one more step essentially. Yep, divide by that. Divide by log base 3 of 2 minus 1. Divide by log base 3 of 2 minus 1. So now what we have is our answer. We will have to rewrite one more time just because. So we have this. X is equal to 1 over log base 3 of 2 minus 1. We don't know how to calculate that, right? We have to do the change of base formula. So our final answer would be this. 1 over, how do we rewrite this? Log of 2 divided by log of 3. So the change of base formula allows us to do minus 1. So when you calculate this, you would need all of this stuff in parentheses on bottom. Let's all make sure we can get that right, guys. So it's a longer decimal than this, but negative 2.7, roughly. Checking our answer, the original was an exponential, so it's all good. We don't need to even check it. Good though. Okay, try this one completely by yourself, and it'll be our last example of equations, because once again, we're dealing with the same problem here. So try it by yourself real quick. Did you all get it this far? Woohoo! That's good. Okay, well if you got that far, then you're probably going to get the right decimal. Okay, sweet. Okay, now there's just these two quick story problems. Well, they're the same thing though. It says, the half-life of plutonium-239 is 24,360 years. The max amount of plutonium-239 that an adult can handle without significant injury is 0.13 micrograms. Suppose that a researcher possesses a 1 gram sample of it. The amount A over time t in years is given by the formula above. It says, how long will it take before 0.9 grams of plutonium-239 is left in the sample? So the question is, should I be plugging in 0.9 into t, or should I be plugging it into A of t? Like, instead of A of t. Replacing A of t, do you see how it says how long? Wouldn't that be finding the t? So you wouldn't plug it in for t. So it says how long? So we're trying to solve for t. So it says, and this is the amount in the end. So it says, how long will it take before it reaches that? So you'd say, so in the end we have 0.9. That's equal to 1 times 1/2 raised to the t divided by 24,360. And now solve for t. So isolate the base. Divide both sides by 1, right? So then you just have your 0.9 equals 1/2 raised to the t divided by 24,360. How do you undo a base of half? Log base of half both sides. So it's just the exact same thing that we just did. So log base of half both sides. Log base of half. So now on this side we have log base of half of 9 is equal to, oh yeah, 0.9 is equal to t divided by 24,360. Get t alone. Yep, times both sides by 24,360. So t times by 24,360 times by 24,360. So t is equal to 24,360 times by log to the base 1/2 of 9, which can't be written like that. We have 24,360 times by log of 9, change your base formula, divided by log of 1/2. And now we can calculate it in our calculator. It's a lot of years. So let's hurry and calculate it. 3,702 years. Then it will be deadly. Take human. Alright, last story problem. Okay, so it says, suppose you deposit $3,000 into an Roth IRA today. If the deposit earns 8% interest compounded quarterly, how much will be in the account after 4 years? Then it says, how long will it take to reach $4,500? So we have two questions here. Let's answer the first one. It says, how much will be in the account after 4 years? Wouldn't I plug that in for t, the 4 years for t? So let's set up our equation. A is equal to our put down amount is 3,000. And then 1 plus our rate is 0.08. N is the number of times that compounds in a year. So 4 raised to the 4 and then t after 4 years. So that's how we calculate that one. Now in this other one it says, how long will it take it to reach 4,500? So that'd be the amount in the end. So now we have 4,500 equals, our put down was 3,000, times by 1 plus our rate is 0.08, divided by n is 4, raised to the nt, so raised to the 4t. So now in this one, solving is easy. You just calculate it. So calculate that. How much would be in the amount in the account after 4 years? Because it's nt, and it says compounded quarterly. That means 4 times in a year. So n is the number of times it compounds in a year. So if it would have said it compounded monthly, we would have put 12, because that means you get interest 12 times in a year. Bi-monthly, we would have put 24. So that's 24 times in a year. So what did we get here? Anyone? $4,118.35. Okay, cool. Okay, it says how long will it take for it to get here? How do we solve for t? Good, divide by 3,000. So now do that. Let's just write down 1.5. So 1.5 is equal to 1 plus 0.08 divided by 4 raised to the 4t. It's going to be prettier if we actually write down what that is inside. So do 0.08 divided by 4 plus 1. So we have 1.5 is equal to 1.02 raised to the 4t. To solve for t, can I divide by 1.02? No, that's not how we undo bases. We log base 1.02 both sides. So now we have log base 1.02 of 1.5 equals 4t. So now divide by 4. Divide by 4, but we would have needed the change your base formula, really. Should have wrote that first, probably, but it doesn't matter. So now we have, on this side, log of 1.5 divided by log of 1.02 divided by 4, correct? Equals t. And that would be our answer, so what would it be? It's going to be around 4 years, just because look how close that was to 4,118, 4,500. This one was 4 years. They would have that much. So 4 point whatever. What is it? 4 point. It's back there on the round table. You'll see it. Oh, 5.1. It could be 5 years. Yeah. So t is equal to 5.1 years. Awesome. Okay, so it's just all the same type of thing. That's the end of the lesson. That lesson was a little bit long.